Hey everybody, it's Michael. I posted my uh, lesson for the week of, well, the first week of March just a little while ago, but it's a pretty complicated lesson and I've never really shared it with anybody before. I took some time this year to really try to figure out a new way to present the idea of atoms being unique with electrons, protons, and neutrons in different configurations. In kind of used an inquiry or investigative methods for the kids to discover what was there, rather than just tell them, hey, look, the periodic tables, based on the number of protons there are and then the electron levels that are being filled, and then the shape of the electrons, the shape of the electron orbitals are also used for structuring the table. Rather than just telling them that, I would rather have them investigate it in some manner, and this is how I chose to do it. These are little manipulative pieces from my math classroom. This is a square. It's green, it's very thin, it weighs approximately 1 gram. Here's the yellow pieces that I talk about in the lesson, and then the red pieces that I speak of in the lesson are small red dots that I got with a paper punch, and this is what it looks like when the kids have them in front of them in their baggies. They're just given this. This is what they have. So when the kids come in and they are about to structure or about to begin the I hope that's not too noisy on the tape there. When they are given 4 things to order, this is literally what they see when they come in and they look at the table. They have these 4 bags, and I just kind of take them and throw them on the table, and I say, put these in some order. And they have, as you can see, they have no real way of telling the difference between the 4 bags. Once they start realizing that there's yellow and green pieces, and then the little red dots, they may take them apart. They may take the pieces out of the bags and count everything. The small groups that I worked with this year, just to see how this would go, didn't make much of a didn't see much of a difference between the yellow and the green. So what ended up happening was they put them in order, the greatest mass to the least mass. And then I said, okay, do you have them in order? And if they didn't have them marked, or if they had them marked 1, 2, 3, 4, or if they didn't have any specifics, I said, okay, here you go. I'd grab them, and then I'd go to the next table and I'd say, are you done with yours? Grab them, take them to a new table. You need to order all 8 of these now. Put them in some order. And what that did was, the first time they had to recount everything, then they started labeling. This is the bag that has the 1 green piece and the 1 red dot. I don't know if you can see it. There it is. 1 red dot and 1 green piece. This needs to be saved toward the end of the processes. Everything else in the room needs to be in order. The kids will have some way. Probably the heaviest mass will be the first one, so this will be the first one in the list, and then the second one will have a little fewer. And then it's pretty striking when somebody shows up in the group and says, hey, I have something that might be considered 1, and then they realize there's one that could be considered a 4 because there are 2 protons, 2 neutrons in it, and then there's a 3 because there are 3 there's a 7 because there's 3 protons and 4 neutrons, and then the next one it goes on and on and on until you get up to the number 20, which is calcium in this process, which has 20 protons, 20 neutrons. The difficulty at the end is that there are 18 protons and 22 neutrons in argon, I believe it is, number 18, and then argon ends up weighing as much as number 20, which is calcium. But then the 19th element actually has more protons than the 18, but weighs less. So if you point that out to them, then they're forced at the end to finally come up with a new way to figure out what the order is, because the last three are out of order, and somebody inevitably comes up with the idea that there's one green one in the first one, there's two green ones in the second one, there's three in the third, four in the fourth, five in the fifth. And then you can have your discussion as to why the yellow ones are in there, how you can figure out how many yellows are in if you look at the atomic number, and those kinds of things. It's very important, however, when you're doing this process, not to talk about protons, neutrons, and electrons, or the periodic table at all until you get finished with the ordering of the 20. If you do, it will confuse things. Kids hear protons, neutrons, and electrons, and they just think, oh my gosh, this must be so complicated. I don't need to be playing with this. Or they get so wrapped up in the idea that they've already seen it that they won't take part in the organizing of the groups. So I hope that shows you how that is, but honestly, the kids just dump these things out, put them back together. You can see why the integrity of the bag and the things that are in the bag is vitally important to doing this activity. All right, I hope whoever gets to evaluate my my lesson gets to watch the video. I'm going to post it on my new YouTube channel, and I hope the lesson is easy to understand what's going on. All right, like I said, I've never shared it with anybody before. Kind of nervous about that because it's all new, and well, I hope somebody will try it. Thanks.